Good morning, everyone. Today we're discussing, or we're looking at the idea of what we call like terms. So we'll go through a little bit of that stuff, but essentially, like terms is the rules regarding whether or not you can plus together um, algebraic equations. So can you plus together something like an A and a B? So I guess it's usually used for simplifying purposes when you end up with an equation or an expression, I should say, that is something A minus something A, whether or not you can actually simplify that down. These are the rules that govern that, right? So first thing I want to show you, so right at the top here, I have A plus A, right? Now, the rules of like terms mean that if you have A plus A, they're considered to be 1A plus 1A, which equals 2A. Right, so it's pretty straightforward. And that might be a little confusing because 2 times A is also 2A, right? But that makes sense when you do it with a regular number. See, I picked 6 randomly. 6 plus 6 is 12. 2 times 6 is 12, right? So it makes sense that A plus A is 2A and 2 times A is 2A. That makes sense. So let's have a look at some of the other examples of how like terms work, and we'll look at how they're collected. So in this case, we have 3A plus A, right? So because there's no number in front of the A, we assume that that's a 1. 3A plus 1A equals 4A, right? So it's just plussing the numbers in front. So I have 6A minus 2A, which is 4A, right? Probably getting the idea of how this works now. 6y minus 7y is negative 1y. Or, seeing as you don't have to write ones, you can just put in negative y. Doesn't really matter, whichever one you prefer. Now where it starts to get more complicated is in this example here. See, we have A's and B's, and the way to think about this is, let's say you're trying to figure out how much fruit you have at home, and you're checking how much you have in your fruit bowl versus how much you've just bought for shopping. You might say, okay, well, we have 3 apples and 4 bananas in the fruit bowl, and then I bought 6 apples and 3 bananas, right? So how much of each fruit do I have now? So you just want to collect the fruit in common, right? So realistically, I want to take this number here, this 6A, and this 3A, and put them together, right? So you can just add across like that, or if you'd be more comfortable getting them all together first, you can actually swap around some of these values here. There's a law in maths called the commutative law, and that essentially means that if there are numbers plus together, you can change the order without changing the result. For example, 5 plus 7 is the same as 7 plus 5. So with that same thought in mind, you can technically swap 6A and 4B around and get something like this. 3A plus 6A plus 4B plus 3B. The only advice I can say is if you do want to move things around, then you make sure you take the sign in front of it with it. So if that's a minus, it has to go with it. So 3A plus 6A is 9A plus 4B plus 3B is 7B, right? Which makes sense. If you had 3 apples before and you bought 6 more, you'd have 9 now. If you had 4 bananas before and you bought 3, you'd have 7 now. So that makes sense. So let's get into some more challenging ones. Alright. Now the question is, with this one, is 3A and 4A squared, are they like terms or not? Which is a good question. Technically no, they're not. So they need to be treated like they are different terms, different pronumerals, I guess. So in the same way as before, I'm going to take this value here making sure I take the sign with it, and I'm going to swap it with this value here, which needs the sign to go with it also. So we're just going to swap those two around. So we're going to have 3a minus 7a plus 4a squared plus 2a squared, right? And then I'm going to solve this. 3a minus 7a is minus 4a. 4a squared plus 2a squared is 6a squared, right? And a way to think about with these ones as to why a and a squared are considered different. Think of it like you have small bags of fruit, right? And you have a bag that just has one apple in it, right? And then you have a bag that has 2 apples in it. And you go, okay, I'm going to count all this fruit, but then you go, oh well, I better sort them out into ones that have singles and ones that have doubles before I go counting all of it. Is a way to think about it, I guess. Alright, let's try the last one, because the last one's a bit of a challenge. So again, I'm going to identify which are the like terms. So there's r squared and r squared, there's r and there's r. I'm going to move these two around, making sure that I'm taking the sign with me. Not that it matters because they have the same sign anyway, but it's just good practice. Alright, I shouldn't turn that. Okay, so we have negative 3r squared minus 5r squared minus 2r minus 8r. Right, and then I'm just collecting these like terms, so the r squares are going together. You get negative 8r squared minus 10r squared. R squared? No, r. Sorry. If it was r squared, I'd be able to collect them again. But no. So it's 8r squared minus 10r. So hopefully that's shed a bit of light on how all this stuff works. Just try and keep the letters need to be exactly the same. Is the best advice I can give you. So give it a shot. If you need any help, let me know. Thanks, guys. Enjoy the rest of your day.